everyone, for today's video, we will now talk about types of diagrams in object-oriented programming. So the first one is activity diagram. An activity diagram visually presents a series of actions or flow of control in a system similar to a flowchart or a data flow diagram. Yung activity diagram is madalas na ginagamit sa business process modeling. And then they can also describe the steps in a use case diagram. And activities modeled can be sequential and concurrent. In both cases, an activity diagram will have a beginning or an initial state and an end or a final state. So, ayun po yung example niya nasa left side po ng presentation. Next naman po, case diagram. A case diagram is a graphical depiction of a user's possible interactions with the system. A case diagram shows various use cases and different types of users the system has and will often be accompanied by other types of diagrams as well. Kadalasan sa case diagram is represented by circles or pwede din yung ellipses. So, ayan po yung example niya nasa right side po ng screen. Makikita naman po natin yung gitna is ellipses po. Ayan po yun. And then the next two diagrams are interaction overview diagram. Interaction overview diagram is one of the 14 types of diagrams of the Unified Modeling Language, which can picture a control flow with nodes and can contain interaction diagrams. Meaning yung interaction overview diagram is katulad lang sa activity diagram. Kasi they both visualize a sequence of activities. And then yung state machine UML diagram naman. A state diagram is a type of diagram used in computer science and related fields to describe the behavior of systems. State diagrams require that the system described is composed of a finite number of gates. Minsan ito talaga yung case pero minsan reasonable abstraction siya. So, ayan po yung dalawang example po natin. Nandyan po makikita din natin sa screen. The next two diagrams naman, sequence UML diagram. A sequence diagram or system sequence diagram shows process interactions arranged in time sequence. Nakapaloob siya sa field ng mga software engineering. And it depicts the processes involved and the sequence of messages exchanged between the processes needed to carry out the functionality. And then yung nasa right side naman is class diagram. In software engineering, a class diagram in the Unified Modeling Language is a type of static structure diagram that describes the structure of a system. So, sa pamamagitan po nito, sa pamamagitan po ito ng pagpapakita ng kanilang system classes, attributes, operations, and the relationships among objects. And then, yung last two diagrams po natin, yung object diagram. An object diagram in the Unified Modeling Language, ito po ay ng complete or partial view ng structure of a modeled system sa specific time. And yung component diagram naman po na nasa right side, in Unified Modeling Language, a component diagram depicts how components are wired together to form larger components or software systems. Ginagamit naman po ito para mailarawan ng structure of arbitrary complex systems. So, magpapakita lang po ako ng example video about sa ibang types of diagrams.
Understanding a software system just by looking at its source code can be very time-consuming. And communicating ideas about software design or business processes is even harder if there is no commonly accepted way to do it. The Unified Modeling Language, in short UML, was introduced to solve this problem. UML is not a textual programming language, but rather a graphical notation, a set of diagrams that help in designing and communicating software systems. We can use these diagrams to describe the objects that form a system and their interactions. UML has many diagram types. We'll be discussing the most common ones. The use case diagram describes the functional model of a system. That is, the functionality of a system from the user's point of view. To describe the structure of a system, UML provides structural diagrams. We'll talk about the class diagram, which can be used to describe a system in terms of objects, attributes, operations, and relations. Last but not least, UML lets us model dynamic behavior too. Behavioral diagrams describe the functionality of the system, focusing on what happens and the interactions between objects. We'll talk about the actual diagrams shortly. The best part about UML is that it's independent of any particular programming language. But we can start coding an object-oriented software based on UML diagrams. And if those diagrams are detailed enough, they can be converted to source code. Now, let's see some ways of using UML in real life. We can quickly draw a diagram to sketch a specific part of a software or a new functionality. I've done that myself on numerous occasions. Whenever something was unclear, I started to sketch UML diagrams before writing a single line of code. The benefit was that I not only understood what I should implement, but I also had a design, a documentation that could be used to communicate my ideas with other team members. Another frequent use of UML is drawing diagrams from existing code. This technique is called reverse engineering, and it helps to understand and document a system. We can also use UML to create the detailed blueprint of a system. While sketches focus only on essential aspects of a system, the blueprint is about completeness. Detailed UML blueprints are usually required for software developed using a waterfall approach, and less frequently for agile projects.
So we are now done to our presentation. Thank you for watching.